Hey guys, we're gonna do differentiating inverse functions today, and this is Advithi. So we're gonna cover defining inverse functions, the reflexive property, the domain, range, and behavior of inverse functions, doing an example on finding the inverse of a function, and then doing derivatives of inverse functions. So to begin with, what is an inverse function? An inverse function is the result of undoing a function. For example, if f of x equals to y, then plugging in y into the inverse of f of x gives us x. In simpler terms, the output becomes the input becomes the output. So what's the reflexive property of the inverse function? So like I said, the output becomes the input becomes the output, or x equals xy becomes yx. That's basically the inverse function. The word-to-word definition is that if the graph of f contains the point AB, if and only if the graph of the inverse contains the point BA. So again, this is the graph of f of x containing the point AB, and this is the graph of its inverse containing BA. It's just that, again, the x of the regular function becomes the y of its inverse and vice versa. Also to note, inverse functions are mirrored across this y equals to x line. The domain and range of an inverse. The range of f of x becomes the domain of its inverse, and the domain of f of x becomes the range of its inverse. Because, again, the outputs become the inputs, and the inputs becomes the outputs. It's seen more clearly in these tables right here. The blue numbers, which are the inputs or x values of f of x, becomes the y values of the inverse, and the y values of the f of x become the x values in its inverse. So behavior of an inverse. As the graph of f of x increases, the graph of its inverse also increases. And as the graph of f of x decreases, the graph of its inverse also decreases. It's seen in this graph right here. The red line is, or not line, but the red graph is f of x equals to negative x cubed, and the blue line is its inverse, negative cube root of, or cube root of negative x. And as the red line decreases, the blue line also decreases. Now, how do we find the inverse equation? We're going to do this example right here, and these are the steps we're going to follow. We're first going to switch the variables and then solve for y. So the function we have is f of x equals to 3x plus 1. First, we're going to switch the x and y and make it x is equal to 3y plus 1. Then we're going to solve for y, and we get x minus 1 over 3. Plugging or substituting the inverse notation in, we get the inverse of f of x is equal to parentheses x minus 1 close parentheses over 3. Finding the derivative of an inverse function. So this is the equation that we're going to use. It's harder to explain, so I'm going to show you some examples and to show how to do it. But basically, this inverse equation is saying that to find the derivative of the inverse function, you have to do 1 over the derivative after you find what the inverse of that function is when you plug in x. So I'm first going to do this example right here, where we have this graph right here, and we're trying to find the equation of the tangent line at x equals to negative 1. So to find the slope, we have to do the inverse of g of x, or h of x, because h of x is equal to the inverse of g of x, and we get, by substituting the value of x of equals negative 1 into this equation right here, we get this equation. I'm not going to read it out loud because I'm probably going to confuse you, but this is what you get. And to find the answer to the inverse of g of x when plugging in negative 1, you have to look at this table right here. And because we're plugging it into the inverse of g of x, not g of x, we have to look at the output values, not x. So the inverse of g of x, when you plug in negative 1, is equal to negative 5. That's the output you get. Basically, it's saying that g of x is equal to negative 1 when x equals to negative 5. So now we have 1 over the derivative of g when x equals to negative 5, and using the graph we get negative 3. So the slope we get is negative 1/3, and then using the point again, negative 1 is the x and negative 5 is the y, because we're dealing with the inverse of g of x, not g of x, and put it in point slope form, and you get this answer. Now our next example and last slide is going to be finding the derivative of f when x equals to negative 1 if f of x is equal to the inverse of g of x. And now we have g of x right here. So the first thing I'm going to do is plug in 1/2 into the first equation we saw right here, because f of x is the inverse of g. And to solve this inside parentheses right here, what is the x value if the y value of g of x is equal to negative 1? We're going to use this equation, and we get the answer of 7. Now we have to plug in 7 into the derivative of g of x. So we find the derivative right here using the formulas we've already learned. And when we plug in 7 into the derivative of g, we get negative 1/20. And since the formula asks us to divide what we get by, or divide 1 by what we get the answer of negative 20. I hope that made sense. Like, share, and subscribe.